Now we'll look at two examples of determining end behavior or long-run behavior of exponential functions. End behavior describes the value of the function or the y value as x approaches the left or as x approaches negative infinity and as x approaches the right or x approaches positive infinity. So let's first determine the end behavior of f of x equals 3 times 2 to the power of x minus 10. We'll first consider as x approaches positive infinity. Well, as x approaches positive infinity, looking at the function, notice how the exponent on base 2 is getting larger and larger, and therefore the function values are getting larger and larger. Therefore, f of x will approach positive infinity. We can easily verify this graphically. As x approaches positive infinity, we're moving toward the right along the function. So as x approaches positive infinity, we'd be moving in this direction here, and notice how the function values, or the y values, increase without bound, and therefore f of x does approach positive infinity. Now let's consider x approaching negative infinity. Well, as x approaches negative infinity, notice how the exponents on the base 2 are now negative and getting smaller and smaller, which means 3 times 2 to the power of x is approaching 0, and since 0 minus 10 is equal to negative 10, as x approaches negative infinity, f of x approaches negative 10. If we look at this graphically, as x approaches negative infinity, we're moving left along the graph. So as we move left along the graph, we can see the function values are approaching negative 10, and therefore as x approaches negative infinity, f of x does approach negative 10. Which also means this exponential function has a horizontal asymptote of y equals negative 10. Let's take a look at a second example. Here we have f of x equals negative 2 times 0.5 raised to the power of x plus 5. Again, we'll first consider as x approaches positive infinity. So as x approaches positive infinity, notice how we would have 0.5 raised to a higher and higher exponent. But each time we multiply by 0.5, the value gets smaller and smaller. So this first product approaches 0, and therefore the function value will approach 0 plus 5, or 5. Looking at this graphically, as x approaches positive infinity, we're moving toward the right along the function. And we can see as we approach the right, the function values do approach positive 5. Which does mean we have a horizontal asymptote of y equals 5 for this exponential function. And now when x approaches negative infinity, it might be a little more difficult to tell, but if we raise a fraction to a negative exponent, and that exponent gets smaller and smaller, the value of that gets larger and larger. So this number is getting larger and larger, but we're multiplying it by a negative number, so this is approaching negative infinity. Looking at it on the graph, as x approaches negative infinity, we're moving left along the graph. As we move left, we can see the y values, or function values, are decreasing without bound, and therefore as x approaches negative infinity, f of x approaches negative infinity. So whenever in doubt about end behavior or long-run behavior, I always recommend analyzing the graph to be sure of the behavior. I hope you found this helpful.